So this lesson is all about volcanoes. In addition to reading and the videos I've got posted on the online management site, I'm going to give you a brief rundown on how to walk through understanding volcanoes. So while there also exist exciting things like kimberlite eruptions and supervolcanoes, the majority of common volcanic eruptions fall into sort of probably about one of four categories, though some will tell you there's many nuances to each and every one of these. And the two metrics we use to divide these categories are gas content. We want gas-rich magma eruptions are going to be very different from gas-poor lavas. And the other big thing that's going to determine what kind of eruption you get is magma temperature. Hot lavas tend to be fairly runny like a soup. Cool lavas tend to be fairly sticky. So we're going to start with a hot lava that has a very low gas content. And you're going to see these are going to form shield volcanoes. So the key thing about a low gas content, high temperature eruption is that your lava is going to travel a very long distance before erupting. So your lava is going to run out quite a good distance. Let's put a little volcanic vent up here. It's going to travel relatively fast for lava, but you can probably still outrun it, so don't panic too much if a volcanic eruption happens. And the next lava flow is going to pile up on top of it. You're going to get, and you're going to get this very broad, gently sloping mountain that is known as and so you get something called a shield volcano. Going to be a type of volcano that's going to erupt. So this is kind of what it looks like in profile view. But if you want to see a more impressive vision of a shield volcano, here we are on Google Earth looking at Reunion Island. In fact, this bugger just erupted fairly recently, so you'll get to watch it in the videos for shield volcanoes. So then we're going to look at cool, sticky eruptions that have high gas content on the other end of the spectrum. So in this case, your magma's coming up like so, but it also has a lot of trapped gas. So gas gets trapped in the magma and gets stuck because the magma is too sticky for the gas to escape. Pressure builds up. When you finally overcome that pressure, magma flies all over the place in lots of little pieces, raining down, and what you get from one of these eruptions is this pile of ash and other stuff. Once the initial explosion subsides, however, you then get a volcano. You'll then get a second layer on top of this ash called of a very sticky running lava that's going to have steep slopes. And so what sort of defines the volcanoes of high gas content and cool sticky lava is these alternating sort of flows of ash and sticky lava. It's because you have these alternate layers that almost look like sedimentary layers and often are mistaken so by the untrained eye. We call them stratovolcanoes. Stratovolcanoes are particularly common in subduction zones where we have all that downgoing slab bringing all that gas and water into below the volcano. So you can see these peaks. I just want you to take a look at these peaks, the pattern, notice their shape, notice their steep sides, notice the steep gullies on them. Notice every one of them. Here's one that looks somewhat freshly erupted. And we can even zoom in a little bit, see if we can even see some of that sort of quote unquote layering that defines a stratovolcano. We may not be able to see it on every one of them, but we'll see it on some, and that'll be awesome too. And when you watch the videos, watch the way the eruptions proceed. Watch a lot of this, because these will be the most dramatic. That's a reason I made these the most. Ooh. Check out this big lake right here. This was once a mountain right here. Now it is a lake because the entire mountain blew its top off. And when the mountain blew its top off, you got the area below the magma chamber suddenly had a big empty spot. The land inside here all subsided and made way for this giant lake. These are very common in areas dominated by stratovolcanoes and subduction zones. So then sometimes you have a sticky, thick magma that's coming up, but there's not much gas. It could be the gas all bubbled out at an earlier time. It could be just there was never any gas to begin with. But still, generally fairly often silica rich, usually on the cool side for magma. Mind you, if you drop your keys in there, you're still in trouble. This stuff's going to run a very short distance, and sometimes even gets stuck so that the lavas are literally pushing up underneath it. And then every now and then a little will escape out the sides, but it won't run very far. And so this regime, where your lava is traveling a very short distance before cooling, and molten lava is often pushing up under solid lava, you get this sort of a rounded structure that is called a plug dome. And as I see, on Mount St. Helens, while Mount St. Helens is primarily a stratovolcano, the more recent resurgence of lava in it since the 1980s, but especially since the early aughts, you've seen primarily a plug dome style of eruption. These eruptions tend to be fairly small, often occurring within larger volcanic systems. Locally, the most recent example of this are the buttes along the south shore of the Salton Sea, all which are classic examples of plug domes. And you can even see sort of this layer. You can imagine this thing sort of growing from underneath. Or if you're looking for one that's a shorter drive away, Calvary Hill, though heavily eroded because it erupted over 20 million years ago, is another stunning example of a plug dome volcano with all of the features of a plug dome volcano, just a little bit more weathered down. So the final style of eruption is when you have a very hot lava, usually basalt, but it can be other things if it's hot enough, with quite a bit of gas in it, high gas content. And what the gas content in this case does is, at this point, the gas can still escape, but just like if you have too many gas bubbles in a soda that the bottle still sort of floods and goes everywhere, when you have a hot running lava that's full of gas, the gas bubbles are going to push it up, creating this sort of fountain-like looking eruption. Now all the material from this eruption is then going to accumulate in sort of a ring of material around this welling up of hot gas-rich lava. I'm going to get this sort of a cone, sometimes almost perfectly circular cone around it, called a cinder cone. Now here we have kind of an interesting one. We have a cinder cone with a plug dome in the middle. This is Panem Crater out by Mono Lake. Now if I zoom out, I just want to ask you, where is the volcano in this picture? What if I told you pretty much everything in this area I am circling was at one point a volcano? So there's a fifth class here. This generally only occurs in continental settings where you have generally a lot of hot material welling up and a lot of continental material. So in the case of this one, this is over by Mammoth Lakes, east of the Sierra. A lot of people love going skiing there from Southern California because, and it's also considered an active volcano and probably one of the more dangerous volcanoes in the state. Mind you, it's also very well monitored. If it goes, we are likely to have enough warning to evacuate the area. So at one point, this whole thing blew up simultaneously, just about, when you had a huge amount of magma underneath here. And a common misconception people have about magma is that it's all just sort of like hot molten rock. No, most magma is actually solid material. It's just when you get a critical mass of liquid, that liquid being a little bit more buoyant, and there's some, and in this case, the lava is getting probably most of its gas from melting of the crustal bits in there. It will go all at once. And just to give you a scale of how large this thing is, this is 30 kilometers across. So now what I want you to do is watch some of the each of the videos of each of the various eruption styles and just sort of notice some of the qualities about them. Then take the quiz on volcanology.